as you see, the name of this, the theme of the conference, computational intelligence. And recently, if you see, in Delhi, there is a summit on AI, impact of AI, that is artificial intelligence. This means the word intelligence is very key element nowadays, because we are using the word artificial before intelligence, and we are using the words computational before intelligence. We are using so many words before intelligence. This means that we are highlighting the word intelligence. The first question is, why do we need this word intelligence? Because I know you always talk about EQ, emotional quotient, you talk about emotional intelligence, there are so many things out there. So, initially, if we look back in 1950, there was a scientist named Alan Turing. He made a machine known as Turing test. Turing test means that there was the development of a machine which was aligned with the human intelligence, and that machine was used to take the test that is known Alan Turing machine. He gave a machine, and the user is on the other side, and he gave some questions, then the user will answer that questions by using the machine. But as the time passes on, then in 1956, the word artificial intelligence was coined. Then this means that when we talk about this artificial intelligence, what does it mean? There was a word, was the conventional artificial intelligence. Conventional artificial intelligence means that it takes so many things. Conventionally, we can make a mimic of the things. Means, suppose this is the device, and I can prepare a device of like this. But as the time passes on, this conventional was replaced by the word computational. Then the artificial intelligence becomes computational artificial intelligence. Computational artificial intelligence, when we talk about this computational artificial intelligence, means that there was a logic behind that in 1956. So to deal such type of things, in 1965, there was a mathematician known as Lotfi. He gave the concept of fuzzy logic. This means he replaced the theory that was given by Cantor. That is crisp set theory, that is classical logic, binary logic. There are so many names of that. So after that, there are so many extensions of this fuzzy logic. This means this fuzzy logic is a very important tool in this computational artificial intelligence. There are some terms, we know neural network is also there. Fuzzy logic is there. So computational intelligence, computational artificial intelligence, if we want to align with the human intelligence. We want to take the things as the human think. The machine will also think in such a way. After that, say there are so many things. There are so many extensions of fuzzy logic, intuitionistic, type 1, type 2, and so many things. After that, Pythagorean, Hermitian, complex, bipolar, hesitant, dual hesitant, so many things over there. Another thing in this talk I will talk about this is code function. This means that when we take, there are some you people, so many people are there. If someone says A, someone says B, someone says C. This means that they are input for me. Now, by taking these inputs, what I can do? This means that I have some methodology, I have to create some algorithm who can deal such all the things.
Voice is not audible, sir. that's different. वो life का है.
So this means कि there are some inputs. After these inputs, they may also happen कि these inputs may not be crisp. If someone of you say कि I am little bit hungry, I am feeling some temperature. So what does it mean some temperature? What does it mean little bit? This means कि you are using linguistic terminology. And as a mathematician, my duty is to convert these linguistic terminology in the form of some mathematics. So these are some inputs. After taking these inputs, I will apply some logic, I will use some inferences. After that, but when I want to get my output, then the output cannot be in the form linguistic. Because if suppose I am a doctor, and I am checking that some person comes to me and he says I am suffering from fever. Now my duty is to check how much is the fever. This is 99, it is 100. Because without knowing this, I cannot diagnose that person. So this means that I will need some methods that will again convert the fuzzy value in some crisp value. So, can we have some alternate of this methodology, defuzzification, fuzzification, inferences which we are doing? We are using inferences. So for that, this term, this core function, can replace this defuzzification, because by doing that, we can save our lot of labor. Agency, multi-objective, multi-choice, transportation model. Multi-objective means कि suppose there are so many objectives, you want to minimize the time, you want to minimize the cost, you want to minimize the carbon emission, you want such type of transportation models that can sustain to our environment, our society. So these are all things, these are the terms which can be used in this talk. So, these are the contents of this talk. First of all, I would like to state some questions and like to place some questions before you. After that, some basic definitions which have been used in that, the mathematical correlations. There are some existing core functions also exist. That what is the novelty of this core function which we are defining here? What are the methodologies, the numerical computations, results, and many other things. So, first of all, our primary goal is to reduce the complexities in logistic environment. Decision makers face some conflicting factors are also there because due to uncertainty. So the primary goal, our primary goal of this is to minimize the transportation cost and sources to destination within time constraints. This means when we talk about the real world problems, the real world problem says that is setting the price of the items. Suppose we have some items and we have to set the prices of that item. So how will you treat such type of things? Another thing, the seller wants its profit. Then how will you deal such type of thing? Another thing, in making choices for multi-objective functions. When your objective is you want to sell, you want to spend small money, you want to spend some minimum time, then there are some objectives too. This means what are the making choices for this multi-objective functions. As you know, Hitchcock, the concept of transportation came in 1941, and this concept was given by Hitchcock. Hitchcock says if there are some products from multiple sources and we have to send these to multiple destinations. So, if you see the transportation problem initially which was given in 1941 by Hitchcock to multi-objective transportation problems. Now we are using the multi-objective, multi-choice, there are so many things are there. So, in single objective, there is one goal, only simpler computation, limited to real world field. But when we talk about the multi-objective transportation problems, we saw multiple goals simultaneously, complex optimizations are there are some complexes, and better real world presentation. So, when we talk about objectives, so in this talk, our objective is to minimize the transportation cost. Our objective is to minimize the delivery time. Our objective is to maximization of the customer satisfaction. Because if the customer is not satisfied, then our all labor will be go waste. Minimizing environment.
75 rand.
That is when we talk about the sustainability. When we talk about this transportations, when we talk carbon emission must be minimum. This means that when we are talking about the transportation, the environmental impact must be considered. So dealing with this uncertainty, fuzzy set theory is used. Why fuzzy set theory? Because we have vague information, we have imprecise data, and human judgment variability. Because some person comes, he says something, another comes, he says something. So there is the variability thing in the human decision, and it will vary from man to man. So, and if we talk about this fuzzy logic, evolution, fuzzy set theory means it handles vague information, and this was the extension of classical sets. But after later on, in 1986, K. Atnasoff gave the concept of intuitistic fuzzy set. This means it also considers membership, means agreement, disagreement, and these all membership and non-membership must be less than or equal to 1. Another thing, when we talk about this hesitant fuzzy set. Hesitant fuzzy set means it introduces the hesitancy degree. Because when you are talking about the membership, you are talking about the non-membership degree. Suppose there may exist some hesitancy. When we come to the dual hesitant means two components. Hesitant, when we are talking about the hesitancy, then we are considering hesitant membership and non-hesitant membership. So this means that this is the duality. And you all, if you see, when you study the evaporation research, there is a concept of duality. If you see the research gaps, there are so many researchers who done fuzzy transportation problem, multi-objective fraction, they take fractional, multi-objective sustainable transportation and so many things, and they gave hesitancy and they gave dual hesitancy. But in this, we have considered multi-objective transportation problem, we have considered the hesitant fuzzy set, as well as we have considered the dual hesitant. So that is why this method which we are proposing here is better than the existing ones. Now, there are 3 questions. Means a traditional score function, that is we want some score, and on the basis of that score we can rank them. So a traditional score function which exists in the literature failed to yield 0 despite differences. So for addressing this demerit, can we develop a score function for improving the discrimination capability between the dual hesitant fuzzy set? first of all, we try to come out with some questions. After that, we start to answer the question. Another, can a score function be developed to provide the better evaluation matrices compared to the existing score function in dual-agent environment? Can we develop a methodology which is robust across different problems instances than existing methodology? So, first we identified some questions. Then we try to answer these questions by developing our concept. So, as I told you, fuzzy set means it is a ordered pair element with its membership grade. When we talk about the crisp set theory, say either the element belongs to the set or element doesn't belong to the set. But in this fuzzy logic, we say the element belongs to the set with some extent, with some grading, with its membership grade. Suppose if you say a set of sunny days, if I ask you, please construct a set of sunny days, then how will you construct? Yeah, if I say set of tall people, suppose there are 10 students in your class and I ask you, please construct the set of 10 tall students, then how will you construct that set? What criteria will you adopt for tallness? Suppose someone says if 6 feet person is tall, another comes say if I have 5.11 inch height, then will you not consider that person into the tall? So we have to consider all these things. Another is interval valued fuzzy set. And in 1975, Z gave the concept of interval valued fuzzy set. This is a mathematical representation of this, and the applications of this: decision making, image processing, medical diagnosis, control system, pattern recognition, and environment modeling. We can use this. So these are some basic definitions. This is the mathematical, this is the graphical representation of that. After that, we come to this P.G.D.A.V fuzzy set. This P.G.D.A.V fuzzy set was introduced in 2010 by Prof. It handles the situation where the decision makers hesitate between several possible membership values. And the mathematical representation means that this is the HX. HX means that this is the set of values in 0, 1 representing the possible membership grade. And if we want to apply this group decision, if we want to take the decision in group, if we want some medical diagnosis, pattern recognition, risk assessment, we can apply this.
हेलो
जी
हेलो
आ रही है आवाज?
हेलो
So now, as we
excuse me sir, voice is not coming.
okay, as we saw score of hesitant fuzzy set. Score means कि suppose let us consider this is the hesitant fuzzy set, and for this hesitant fuzzy set we can define the existing node function which is defined by this, where is the in this S of Hi are called the score values.
Sir, just one second. Is the problem solved? Now voice is coming.
ठीक है. Now we come to the
Hello?
dual hesitant fuzzy sets, and the dual hesitant
Hello?
concept. Yes.
सुनाई नहीं.
Dual hesitant fuzzy set. This was introduced in 2000.
Voice is not going so.
हाँ ये भी नहीं है.
So that mic is for the live one, so you can clip it only. It's not working for that.
Okay, so this one will work?
So I guess this will be yes.
इसको देखिए.
सर वो आप पहन के रखिए.
तो दोनों लगाने हैं क्या? So next we come to the dual agent fungicide, and this concept was introduced by Zhu in 2012, and it was the extension of the hesitant fungicide. Hesitant fungicide, and this is the mathematical representation. Typically, in this we have the set of possible membership values and set of non-membership values. If we talk about the key innovations of, because it captures the hesitancy both in membership as well as the non-membership degree, and it provides the most comprehensive uncertainty representation. If we talk about the applications of this dual hesitant fungicide, when we talk about the complex multi-criteria decision making, when we talk about the supplier selection problem, personal evaluation, environmental assessment, so we can use this dual hesitant fungicide. So, the dual hesitant fungicide may also satisfy the following criteria when we talk about the total uncertainty, total ill knowledge, and non sensical elements. So, these are the some arithmetic operations on this dual hesitant fungicide. I will not go in detail of this because this.
Hello?
G, yes.
Hello?
Now, this is the
Hello?
no. Hello. आवाज आ रही है क्या?
Hello? Ma'am, am I audible now? Hello? Ma'am, am I audible now? Am I audible now, ma'am? Hello?
ब्लिंक नहीं कर रहा इसे अभी इसे 1 मिनट. हेलो. नहीं आ रही आवाज नहीं, वो ब्लिंक ही नहीं कर रहा. ठीक. Now we come to the novel score function of dual hesitant fungicides. Suppose let we say D be the dual hesitant fungicides, then this proposed score function is denoted by this KD of and the proposed score functions methodology basically when we talk about this transportation problems, multi-objective transportation. इसका वो नहीं है क्या? And by using this we can ranking of the dual hesitant fungicides if k of d1 greater than k of 2 if and only if d1 is greater than, otherwise it will less if d1 is less than d2. So क्या है वो क्या रहा? इसका वो ना इसको दोबारा से करो तुम, इसका वो साइड में वो लाओ जो आता ना.
चलो हेलो नहीं हो रहा यार वो करो पहले तो इसको प्रेजेंटेशन करो ना now we come to the multi-objective transportation problem the mathematical structure of this mathematical because we have to optimize with respect to some constants and the type may be it may be balanced or it may be unbalanced. So when we talk about the mathematical formulation in context with the dual hesitant fuzzy transportation model, it was given by Matty et al. And suppose let us consider the dual hesitant fuzzy cost where with the both membership and unknown membership. And this is the optimal solution for the optimization problem. After that, these are some basic things. And this is the proposed model for dual hesitant fuzzy multi-objective transportation problem. In this, we have taken the membership, non-membership, hesitant values, and the optimal solution of the with respect to the constants, we have to maximize, minimize with respect to the there. Suppose dual hesitant fuzzy multi-objective transportation problem. First, it will be converted into LPP with the two desired objective functions because we have to optimize the customer satisfaction and we have to minimize the cost. We have to minimize the transportation time. So the existing score function, this one, yeah. Hmm? नहीं, अभी नहीं चल रहा। अब ये नहीं चल रहा अपना इनका रिमोट हैं ये तो हो गया। हम्म? हाँ चलिए इसी पे आता हूँ। The modified proposed methodology in this first step we considered all the parameters in the dual hesitant fuzzy optimization. Now both existing and non-existing score function क्या हुआ? वो दोबारा करना अच्छा so to maintain the equilibrium of multi-objective we have to ठीक है हम्म हम्म So if you see, first of all, the tabular representation of the selected problem. After that, all parameters will be converted into the dual hesitant fuzzy multi-objective. transportation data into crisp form by using the proposed the score function which we have given here. After that, we will check the problem is equilibrium or not. If no, then transform of the balanced dual agitant multi-fuzzy object transportation problem into the balanced. If yes, then we will find the allocations by using the proposed methodology which we have proposed here. And if no, then after that we will use the arithmetic operations which we have defined on this score function for each every row and column. After that, we will try to find out the penalty of each row and column by using this formula, means if Cij maximum minus Cij minimum of that. And after that, select the maximum penalty for each row and column and assign the main supply demand to the each cell. If there is a tie, then the maximum penalty for a column and a row, then we will try to choose the minimum of Cij corresponding to that penalty value. After that, if the supply and demand is satisfied for each and every row, then we will find its optimal solution. After that, the method will be complete. So if you see the numerical computations, in this numerical computations we are trying uh, hmm, suppose there is a logistic company, and if this logistic company has two warehouses and supplying goods to two retail outlets D1 and D2. The aim of this is to optimize the three conflicting objectives. The three conflicting objective means we have to optimize the transportation cost, we have to optimize the transportation time, and we have to optimize the environmental impact. So due to the uncertainty and the decision maker hesitant, the problem is given by the dual hesitant. We have taken the dual hesitant fuzzy sets in the form of the supply, in the form of the outlets. So, and this these are the numerical values. So this will be by converted the crisp form of dual adjutant by the multi-objective by the this is the existing score function and this is the proposed score functions. If you see the results of the ever problem in the dual adjutant, this is the existing and this is the proposed, and these are by this the existing methodology and this is the proposed methodology. So another problem, suppose we have three cities, New Delhi, Kolkata, Mumbai, and there are affected cities Guwahati, Patna, and Ranchi. And the organization aims to optimize the three conflicting objectives that is in the previous problem, that is the transportation cost, transportation time, and impact environmental impact. That is, we try to reduce the carbon emission. So these are the numerical computations. So the crisp. So this is the result, the existing score function, the proposed score function, and by using the dual adjutant fuzzy score functions. So the comparison of the existing and the proposed score function, we will see the results of the numerical calculation shows the proposed methodology is far less expensive to implement the existing one. And the existing methodologies was combined with the purpose to build the score functions, and the cost was reduced by this. So this is the graphical representation of that we have used. These are the limitations of this. The work is limited to assume the constant conditions across various test scenarios and potentially oversimplifying the real world complexities in the transportation models. And if we talk about the feature scope means if we want to enhance the decision making by developing the hybrid models and that integrate with the dual agent fuzzy methods with Other optimization techniques, further investigations in geographic. In fact, if we take GIS, geographic information system can be combined. In future, we can also develop the advanced model that can accurately represent the transportation choices of users by incorporating the dual hesitant fuzzy set to capture their preferences and behaviors. And to validate this dual hesitant approach in practical transportation scenario, it can be conducted in the real world case studies also. These are some references. Thank you. Any other you? They are working in the this fuzzy, and there are many because zoo ZHOU at all, ZHOU, ZU Kaylee Kingley Kangley. He also written a book by Springer on the fuzzy set interpretations. KHL.
Even that is over. Thank you so much. And today's the topic of the presentation is some glimpses of population ecology model. Thank you so much. On the first of all, I must thank the organizers, in particular Shubham, for adjusting my request for changeover of the slots. That was inevitable because of my other commitments. So, quick, I have half an hour or 40 minutes. What's that time? 40 minutes. Okay, let me just check up. So, I'm talking about population ecological models, and I will be talking about first one species model, then two species model, and then some considerations which will come into picture. This essentially reflects the work of my former student who is presently the faculty at BHU, and he is also here to give a talk afterwards. So this it is his research work which I am presenting here to some extent. So what is ecology? To first of all, it is essentially the study of organisms and their interaction with the environment. And the scope of this is very huge. And because it also talks about the interaction with the environment, and it can be at different levels. For example, it can be organizable ecology, population ecology, community ecology, ecosystem ecology, and so on and so forth. In particular, we will consider population, yeah, we will consider population ecology at this stage. So let's say one species population model essentially says that there is a particular organism. It could be anything. It could be a certain species for which we are talking about, and it has growth. So there is a certain growth rate which says that the growth rate is proportional to the population present at any given time. So here this R depends, this R is essentially the difference between the birth rate and death rate. So no other consideration has been taken care of here. What does it mean is that in case the birth rate is more than the death rate, this will always be positive and the population will keep growing at this stage. But in case R is negative, that is the death rate is more than the birth rate, then ultimately the population will decay here. But this is this model has very limited use. It can be, it is helpful when you are looking for a small time, but not for a long time, because if you see that R is positive, it implies that it will grow exponentially, which is not possible. But certain species, certain organisms, this is fair enough when the growth is very high. Okay, may not work for the population model, but it will work for some other species there. So the next modification came that the population reaches a certain carrying capacity, that it does not grow beyond certain limit. That could be limitation because of space, it could be limitation because of food, it could be limitation because of environmental effects. Therefore, it says that in case n is the population, then the logistic growth rate is given by this quantity. This R is known as the growth rate and K is the carrying capacity. So what we notice here is that as soon as n reaches K, the dn by dt becomes 0. Therefore, population stays at that stage ultimately. Okay. So the growth rate of organisms can be influenced by variety of circumstances, and there are different growth rates which have been proposed, which have been reported. For example, Malthusian growth rate, logistic growth rate, food limited growth rate, and so on and so forth. Many of the population models consider the logistic growth rate, but there are other things are also possible in this case, which we will see. Now, then let's say two species model, where we are considering prey-predator model, which is very well known in the literature, right? So what we make, when you talk of model, we always make certain assumptions, certain simplifications are being made. So the assumptions here are that predators can survive only on the prey population. In case there is no prey population, they will not be able to survive. Okay. The total amount of food consumed by the predator per unit time is proportional to the number of attacks on the prey population by the predator. We will come back to that later on, but at the moment, please keep it in mind. The number of attacks by the predator on prey population is proportional to the size or density of both prey and predator. Each predator needs a minimum amount of food to survive and reproduce. So the predator needs to, to be fed on the prey. And each prey has unlimited amount of food that helps it to reproduce in the absence of predator. That means in the absence of predator, the prey can grow unlimited. Okay, the growth rate is unlimited. So conceptually, what it says that in case n is a prey and p is the predator, then the growth rate of prey is the growth rate of prey population in the absence of predator minus the capture rate of the prey by predator. So the way it is being attacked by the predator, that counts there. And this is essentially the rate of change of predator is the decline rate of predator population in the absence of prey. Because in case there is no prey, they will keep dying. So therefore, there is a decline of the predator. And once they eat the prey, they attack the prey, then the contribution of eating prey into the growth of predator. So this is a simple formulation on which the whole theory is based here. Now, next thing what we are talking about is the harvesting. What is harvesting? Harvesting involves the removal of individuals from a population because of various reasons. It could be, for example, agricultural harvesting. For example, if we want to cut the trees for paper production. It could be fisheries. Down. From here. Next one. So what is harvesting? Harvesting essentially is the removal of individuals from a population. For example, when I talked about agriculture harvesting, fisheries harvesting is anyway there. Fisheries for commercial purposes. Then wildlife harvesting, that population control, so that the animals do not grow unlimitedly. Forestry harvesting, removal of specific trees for the growth of the other tree. So then can be different type of harvesting possible there. And this is very important from the sustainability point of view of the environment also. So as I said here, the need of harvesting is balancing it. It requires scenarios requiring harvesting is it becomes necessary whenever the population exceeds a carrying capacity or the resource utilization. It involves balancing of resource utilization to meet the human needs with the conservation of a species in an ecosystem. Type of, can you slightly put it up? नहीं यहाँ मतलब पूरा वो नहीं आ रहा है ना now it's okay. Now it's okay. So selective means you are removing only certain type of species, not all the species are being removed there. Non-selective, that is without any discrimination, the individuals are removed. Sustainable harvesting is the one which is very important, which ensures that the population can regenerate and persist. The coexistence of the species are also important. So it could be because of scientific research, it could be because of the sustainability, and management strategies are also important. So there could be various reasons for harvesting which can be considered. But in particular, I would say sustainable harvesting practices are designed to ensure the populations are not depleted, because you don't want extinction of any population here. Therefore, they are not depleted to the point of endangerment and ecosystem remain in balance. This is very, very interesting and important. Now, there are different type of, mathematically, how do we take care of this? So there are different type of harvesting functions. One is constant harvesting, that is the population is harvested at a constant rate. Second is proportional harvesting, that it is proportional to the size of the population, where Q is the catchability coefficient, the way it is being caught, and then E is the effort applied to harvest individuals. Nonlinear harvesting is, this will stay there? Okay, so I will keep doing it, right? So this is, as you see, that this is nonlinear harvesting, because one of the drawbacks here is that in case effort is more, this will keep increasing. In case the population is more, you have to harvest more here. But this does not happen here. There will be a certain limit which will be taken care of here. So it allows for the preservation of age, size, or sex structure of the population. This can help maintain the diversity and stability of the population, which is often disrupted by the linear harvesting. So these are essentially the modification one by one, looking at the what is the disadvantage of the previous one. So you come to this one, you come to this one, and so on and so forth. Sometimes it works. ऊपर हो गया इसका थोड़ा नहीं, ये तो था वर्क okay, that's fine, that's fine. So let's look at the harvesting with a one species model, because that's the simplest thing to do it here. And what we are considering here is a logistic growth model. This is a logistic growth model which I said earlier, and then this is the harvesting which is proportional to the size of the population here, right? So R and K are the growth rates and carrying capacity respectively, and harvest rate represents the fishing effort, that how much effort is made for harvesting the fishing. Q shows the catchability coefficient, that means how much, what is the amount of the fish which have been caught, which have been harvested here. This is a proportionality constant, and therefore if we look at it, we have got two steady states. That means two steady state means dn by dt is equal to 0 after time t going to infinity. What will be the state of affairs with the population here? So which you can get it from here. So one of them is n star is equal to 0, and another is n star is equal to k into 1 minus 2e upon r, which you can get it immediately from here. Now, what we notice from here is that if you look at this equation, this dn by dt remains positive whenever this is greater than this quantity, and it becomes negative whenever this effort becomes more as compared to the logistic growth here, right? So this what is we are trying to depict here, that if you draw that rate of change of population, and then this is the parabolic curve with respect to Rn, this is a logistic growth rate, and this is the effort which is linear here. So what it says is that there are two steady state point or the equilibrium populations. One is 0 and other is n star. So whenever it is here, we see that this is always greater than this quantity. Therefore, dn by dt is positive. Therefore, population is moving away from 0. Therefore, this will always be unstable here. But whenever you are coming to n star, you see that at this stage, this line at any point is greater than, the value is greater than the parabolic part. Therefore, dn by dt is negative. Therefore, this will be moving towards n star. And whenever you are this side, this is moving this side. Therefore, this n star is stable, right? So this tells us about the low mortality harvesting here. In case we keep increasing the effort, therefore, this line which was like this, it will keep shifting like this. Therefore, this n star will keep shifting towards the trivial point. Okay. So this is what, this is high mortality, and therefore it will just keep shifting like this here. But what is more important is that if we further increase it here, yeah, if we further increase, this will come to this side, and there is no n star coming. There will be only one point here. Okay, and now this will become stable, while earlier it was unstable here. So this gives us an interesting point. Yeah, the location of steady state is a function of fishing mortality, because we are looking at the parameter. So it says that up to r, this is stable, this n star is stable here, and the origin is unstable. But beyond this, this becomes unstable, this becomes, origin becomes stable, and this becomes unstable. Of course, negative dn n star does not make any sense biologically, but from mathematical point of view, we are seeing that this becomes unstable here. Yeah. So this gives us different type of bifurcation. So this tells us that there is a transcritical bifurcation, because the two collide and exchange stability at this point at QE is equal to R. Another point which needs to be studied is the yield at the equilibrium n star, or how much is the yield of the what is the yield of the harvesting at n star, which is given by this quantity, and which is, of course, it's a parabola, and the maximum is attained at Rk upon 4. So this is the maximum yield, optimal level of effort which is required to get the position is given by R upon 2. So we can estimate what is the effort required to get the maximum yield at this stage. Yeah, there is another type of growth which is not exactly the logistic growth, but it is slightly more than that. And it says that, yeah, there is a threshold to the growth. So if it is less than k naught, it reaches a certain point. If it is more than k naught, it reaches a certain point and then it stops there. And therefore, it is a function. This is the rate of change of population goes like this and then like this here. So there is a critical dispensation which comes at this point here. And if you look at this, it has two non-trivial steady states. At any point, you get one steady state here, one steady state here. And when you keep moving with effort, this is stable and this is unstable. One of them is stable, other is lower one is unstable. And ultimately, they quickly generate an interesting bifurcation diagram, and you get a saddle node because they it at this stage. It just gives us a saddle node bifurcation here. Now we come to two species model. So if you look at the first term, this is essentially the logistic growth of the prey. And if you look at the second term, this is the death rate of the predator in the absence of prey. Now, what is this term and this term? This is essentially the interaction of the population of the prey and the predator. That is the way predator is attacking the prey. So this is what it says here. and this was given by Zio and Jennings, and they proposed a constant type of prey harvesting in this model here. This is basically ratio dependent model, because in case n and p both are 0, this is not really defined at this stage. Therefore, this is known as a ratio dependent model here. So from here, it is noted that, see, why I'm not really going in the mathematical analysis of this thing, because that becomes slightly involved. What is required here is that we are giving you the models. I am trying to give you the model and the results containing it. Sometimes I am giving the ecological result, but mainly looking at the dynamical system, and then from mathematical point of view, what are important results, they are coming here. So this says that as the value of the parameters of the model vary, R, A, H, this is being non-dimensionalized, and with respect to that non-dimensionalization, when we change different values of the parameters, we notice different type of bifurcations. For example, you can see it here. So it gives a rich dynamics of bifurcations of the dynamical system, which is only two species model. It gives a rich dynamics at this stage. H, this is the harvesting, constant harvesting, right? That's what it says, that now, so far the model is fine, but now harvesting, H is there. So this is the first model. I mean, this earlier model I had considered proportionate harvesting, one species one. Now it is a constant harvesting. Now we will keep adding one by one more complications. So this is harvesting in the prey. People have considered other type of harvesting, which we will come now. Yeah. Now you are considering constant harvesting in predator. So this has again obtained richer dynamics compared to the model with a no harvesting, and different dynamics compared to the model with a non-zero constant rate harvesting here. So again, from the mathematical analysis point of view, this becomes more important for us. This, of course, Z only, they have given this one. Now, in this case, there is a constant harvesting in both prey and predator. Depending upon the situation, we get different type of harvestings, which will come into picture here. Phi n is essentially a certain function with respect to n. There's a prey population. A n, this anyway is defined here. C is a conversion factor. That means how much the prey which has been attacked, how much it has been converted for the growth of the population here, right? Number of newly born predators from each captured prey. Mu and H1 are the constants harvesting, and A represents the functional response of the predator. So this is what the point is. So if the harvesting is at the rate for which no equilibrium exists, then the extinction of both species results. And what is interesting is that the existence of equilibrium may not be sufficient to guarantee the biological resources stocks would not be exploited too heavily without an ultimate loss of productivity. So ultimately, this may give rise to the loss of the productivity. So it also shows that, yeah, what I wanted to say, yes, in case it has two equilibrium intermediate points in the first quadrant. Why we are saying first quadrant? Because the population need to be positive all the way. We cannot have negative populations. Therefore, in both the cases, it need to be positive. So first quadrant is important here. System possesses only a set of measures 0 on which both the species coexist. That means in case there is a small perturbation from there, this will go to extinction there. So this is extremely susceptible to a collapse under the small perturbations here. Yeah. So some interpretation with the biological result is also given here. This is okay. ऊपर जाएगा. So now so far we consider constant harvesting. Now we are going to the linear harvesting. So many people have considered this. Yeah. Prey is continuously being harvested at constant rate. So this is also considered constant harvesting, the predator equation. And Chakravarti et al. Made a reasonable assumption in the sense that harvesting is proportional to the density of the harvested species. So this is modification of the previous models. So Chakravarti essentially considered this one. This is again constant. E is the external effort devoted to the predator harvesting, and B naught is the conversion rate. But this is exactly same. Let me just check. Yes, it is here. TK Kerr essentially has done a lot of work in this direction, and this is why I want to basically put it here. So they have considered, no, this is again functional response for the predator on the prey, and this is essentially the linear proportionate harvesting for prey, and this is for the predator. So this essentially this says that beta n upon 1 plus alpha n denotes the functional response of the predator, which is known as a Holling type 2 response function. Those who have been working in this direction will know there are different type of response function. Yeah. So they know that there are different type of Holling type response functions. So this second type of response function, the model incorporates a refuge protecting the prey. That means there's certain amount of prey which has been, they get a refuge protection, and this leaves only so much, because not all the prey have been preyed. This leaves only 1 minus m into n of the prey available to the predator. So they get some refuge at some stage. This is essentially some of the our work. Of course, it's an old one, but uh, yeah, 2012. So this is essentially considering two competing species. They are compete with each other in the environment. They are toxic and they are competing with respect to each other. So this is, as we have seen earlier, this is a linear interaction of the predator and prey. This is because of the toxicity of the predator, prey which has on the predator, and this is the toxicity of prey on the predator. So this is a different one, and then this is linear harvesting in both the cases here. So they are telling us that denote the intrinsic growth rates. They are here. Carrying capacity for both of them are there. Coefficient of interspecific competition and toxicity coefficient of the ith species from here and here. Yes. Now, so far we have considered only linear one. This is nonlinear one which is being considered here. So they are the positive constant. M1 and M2 are constant. This A1 is the maximum value for the per capita reduction of rate of prey, N measures the extent to which the environment provides protection. This is a protection provided to the prey and predator respectively, and S measures the growth rate of the predator species, and SA2 is the maximum value of the prey per capita production rate of the predator. This was a very interesting paper, and it has been cited number of times. So this is another work where nonlinear harvesting is being considered. This is predation, this is also predation, this is death rate, this is logistic growth rate, and then this is what is coming here. So okay. So open access fishery, where the fish population depends partially on a resource. So this is what essentially coming here. Yes, this is essentially the predation of the prey, and this is again predation. I mean, this is the positive point, and this is the negative side here. And this is now this effort here. So far, we have considered effort to be constant, but now this effort also depends upon time, and this is what, because suppose there is a taxation which is given that you cannot harvest more than this. If you do it, there will be penalty on this, and therefore this tau essentially talks of this, imposes a tax here per unit biomass of the landed fish, and tau the subsidy given to the fishermen. Therefore, looking at it, this effort essentially depends upon time, and therefore this is no more constant. This is a function of time here, and this is also depending upon p. So they are non-linear. All of them have been non-linear, but this is three-dimensional case which is being considered here. So this model essentially looking at the prey predator scavenger model. That means this population depends not only on the, see, this is a predator, this predates on this, but this population depends not only it on the population here, it also depends on the population. Yeah, this depends on this as well as on this one. That means uh, the people who have died, I mean the prey which have died, that population also comes at this stage. They eat that population. So this population depends upon this as well as on this population here. So there is a, what I want to say basically is that this is a predator and this is a scavenger. So both of them eat the prey here. So this is of course death rate of n. This is death rate of, this should be p. Sorry, this should be p, and then this is p squared is the population there. So this is essentially the effort coming here. So this H1 and H2 represent the rate of harvesting of predator and scavenger population respectively. H1 and H2. So there is a population here which is coming there, and they are not linear. They are non-linear here. The authors conclude that all the three species have unpredictable and irregular behavior, which may be controlled with the help of appropriate amount of harvesting, so the system can be dynamically balanced. Just finish it in a couple of minutes. So this is one of the recent studies by Gupta and et al. So they consider current population density, which feeds both prey and predator. So earlier it was just on this one, but now this feeds on predator also. So in view of this, the assumption is modified. This again is nonlinear harvesting, which is being considered here, and then E is the natural death rate of the population insect. So there could be, I mean, these are some of the models which I have presented here. There are certain many important contributions in the and developments in the field of predator and prey models with harvesting since the Lotka-Vodka models, and there are some of the key contributions or our development here. So sustainability and optimal harvesting has been one of the very important aspects from mathematical formulation to determine the sustainable harvesting levels. Researchers have explored that optimal harvesting, how much optimal harvesting can be done so that the extinction of either of the population does not take place. With control rules, so this can help the scientists and the policymakers. Anyway, I will just go with this one. So there's no other model. Harvesting of it's okay. So we just saw two models where the multiple species harvesting was there. So there can be more such models which can be considered. Ecosystem based management. The concept of ecosystem based management and has gained prominence in the recent years to consider the broader ecological context when designing harvesting regulations. So mathematically, that's what I would like to say. Mathematically, we get a lot of rich dynamical behavior from these models, and this is challenge for mathematicians to look at this not only from ecological point of view, even from the mathematical point of view. So I'm just listing some of them. One can take care of that. So I would like to acknowledge it to Ravi Gupta and thank you. I mean, as you can see that emphasis is on models and giving the basics of how to improve the models one by one. Well, it is more of a review. That's what is some glimpses, not the analysis.
Not on a particular model.
Anyway, yeah.
That's what I was the students or the budding researchers will not get frequent opportunity to meet a researcher like that. So if you have any questions or please you can.
There will be more detailed analysis. He will be presenting in one of the invited talks. Ravi Gupta. He's there. Ravi Gupta is there.
Your student.
Well, one of my last students. I would say the last student. But now presently he is in the faculty at BHU.
No questions from anyone? Sir, any questions? So thank you, sir, for such a nice presentation on ecological modeling and especially with harvesting.
Yeah.
So,
in fact, Professor Carr and his group has done a lot of work. And
from Shipur?
Shipur.
Yeah.
And Tapan Kumar. And of course, we have carried on forward in different directions. But there are a lot of people are working in this direction. So sure, please.